Okay, this is 46 worked out on the board.
Okay, we good to go? Okay, 47. Another square root problem. This one's interesting. I love this next problem. But you have to have a common knowledge of square roots. Is that funny? Are y'all good on square roots, bad on square roots? Don't want to do square roots. I don't know why they call me crazy. I'm a crazy math teacher. I love radical problems. Maybe because I put up with radical kids all the time. I don't know. Let's look at this one. This is number 47. 3x times the square root of 50. I don't have my glasses on. Okay. If I hold it out far enough, I'll see. Square root of 32x squared equals square root of 18. But that one looks virtually impossible, and you think, well, we're supposed to isolate the radical. Well, how are we going to isolate any? We can't isolate just one radical. So this is what I propose we do. Square root of 50. Same thing as 5 square root of 2. Do y'all agree? Okay. Square root of 32. Same thing as 4 square root of 2. Notice a common relationship. Square root of 18. Same thing as 3 square root of 2. Okay. What's the square root of x squared? Okay, it's really in all essence plus or minus x, but you don't have to worry about that on ACT. You just have to know it's x. So basically what we have here is we have 3x times 5 square root of 2. Here we have 4x square root of 2. And there I go again. I did it again. And here we have 3 square root of 2. Anytime you've got the same radical in all your expressions, you can add, subtract, multiply, divide. You can do whatever you want to with them. This becomes 15x square root of 2 minus 4x square root of 2 equals 3 square root of 2. So what I want you to focus on is 15x minus 4x. What is that? 11x square root of 2 equals 3 square root of 2. Imagine this. What if we divided the whole thing by square root of 2? It would disappear and you'd have 11x equals 3. Therefore, x equals 3/11. Boom. You got your answer. And I shut my book, so I don't know which answer that is. C.
On page 168.
Okay. There we go. What do y'all think about that one? That's one of those problems you look at it and go, ah, what am I going to do? Wait a minute. And it worked out so nicely. I mean, the answer's not real nice, but I mean, it could be worse. 48. Solving for x on a linear equation. It will take me probably longer to write it than it will for some of y'all to solve it. This is basic. I'll do negative 2 times x minus 7 plus x minus 6 equals 23. We're solving for x. Negative 2x plus 14 plus x minus 6. We get a negative x plus 8 equals 23. And I know some of y'all could have found that answer without doing all that. I know you could. I can tell. So on the ACT, you don't have to worry about all that. Some of y'all could have taken this and probably found the answer real easy. It's just working on your mechanics of solving an equation for x. The answer is negative 15, which is answer choice G. How we doing? And I'm not trying to make y'all feel bad if y'all can't work this with just looking at it. I can't always do that, and I've been doing this for 26 years. I've been doing this for longer than 26 years. People went through junior high, high school, I don't know how many years of college. Still going to school, so you never stop learning. Okay, the next one, find the area of an equilateral triangle with side length of 12. Here's some geometry we need to know. First thing I usually do, I'm a very pictorial person. I draw a picture. Which my pictures are not just real super accurate, but I know I've got an equilateral triangle. All my sides are equal and they equal 12. Well, I know if I'm finding the area, I need the height. That's the perpendicular distance from the top to the base. It splits the base in half, so I know this is a 6 and this is a 6. Equilateral triangle, I know this is 60. This is 30. Special right triangles, what's my height? 6.
Square root of 2.
Nope.
Square root of 3.
Square root of 3. Very good. 6 square root of 3. Area of a triangle is 1/2 base times height. The base times height divided by 2, however you want to write it. 1/2 12 times 6 square root of 3. Half 12 is 6. 6 times 6 is 36. 36 square root of 3. Is that one of our choices, or do we need to multiply it out? That's one of our choices. Can y'all tell I teach tax? Because they sometimes do it in simplest radical form. Sometimes they multiply it out. Any questions? Okay, the next question is it should be 50. I can't see my numbers. Determine the point of intersection of the following system of equations. Okay, there's multiple ways to work this. You can do it by graphing on the calculator and do second trace, and I'm sorry to the Casio people because I don't know what y'all's sequence is. Is it still second trace? Cool. And then you go to intersection and just enter, and it'll tell you your intersection. But the problem with that one is you have to have both of the equations in y equal form. You'll notice the first equation they gave us is y equal negative 1/2 x. Let me see. I've lost my place. Plus 14 or 13/4. Okay, and the next one is negative 2x plus 3y equals 8. Okay, thank you. Okay, you get to pick the method here. I don't like doing graphing because to me, like Ms. Weisner said, when you pull that calculator out, you're wasting time. You're killing time because you got to pull it out, turn it on if it's not on, and get everything ready. So what I'm going to do is I'm going to multiply everything here by 4 and write a new equation. I get 4y equal negative 2x plus 13. Y'all agree? Guess I could write times 4 here. Okay. I'm going to move the y over here with this and move the 13 over. Make sure you understand. Wait, no, take that back. I want to do it the other way. I'm going to move the x over to be with the y. That's what I want to do. I just added the x over to be with that. Now look at these two equations. I've got the one they gave us, and I've got my new one. I'm going to solve by elimination. The x's cancel. You get 7y equals 21. Y equals 3. But look at your problems and see if you can eliminate any of them. No, well you could, I guess. F into 3. Yes, you could eliminate those. Well then just take it. I go back to the nice one they gave us. Negative 2x plus 3y equal 8. That's just my preference though. And I've got negative 2x plus 3 times 3 is 9 equals 8. Negative 2x equals negative 1. X is going to equal 1/2. So that would be H. (0.5, 3). Keep in mind, you've got knowledge of this. There's several different ways. There's graphing, there's a substitution, there's elimination, or a combination, however you worded it. There's the matrix method on the calculator. That one, to me, takes too long. But if you don't know any of the other methods, that would be the one to go for. Okay, on the next one, it's a kite problem. Which of the following is not true for a kite? Again, you have to have knowledge of a kite. Remember that with a kite, one diagonal bisects the other. They intersect to form right angles. This doesn't look like right angles, but they're going to be. Obviously, this is the segment that the diagonal that got bisected. Let's see, A, D, C, and then E and B. Okay, let's look at it. AE congruent to CE. We know that's true. So our answer choice A is out because we want to find the one that's not true. DE is congruent to BE. No, that one's not true. That looks like it's going to be our answer. Something else I forgot to mark is consecutive sides are congruent on kites. Okay, angle ABE is congruent to angle CBE. Yes, because another fact that you may not know is with kites, the diagonals bisect these two angles. They bisect angle D and B. They do not bisect angle A and C. So that means that this angle is congruent to this angle is congruent to this angle. So answer C is out. D, angle E is 90. That's out because it is equal to 90, we know that. Angle ADB is congruent to angle CDB. Well, we know that's a fact, so your answer here is B. Process of elimination on that one, but again, you have to have knowledge of kites. So you might want to, before you take this test next time, review your quadrilateral relationships. Okay, 52. Tony has an A average on in his math class. There's one test left. In order to keep the A, he will have to maintain an average test score that is at least 90%. He has completed 5 out of the 6 tests, and his current average is 91%. Which of the following scores is the lowest he can earn while still maintaining an A? What I propose is, you know that he's got a 91 average on 5 tests. He's got a 91 average on 5 tests. We don't know what that 6th test is. But if we take it and divide this by 6, we need that to be 90, right? So I just set up that equation. You don't know specifically what each test was, but you do know that the average is 91, so that means that all those scores added up divided by 5 equal 91. So 91 times 5 has to equal the sum of those first 5 tests. So keep in mind, this is the sum of first 5 exams. This thing right here. So you add that 6th exam in, divide by 6, you have your average. So we're looking at 455 plus X equals 540. Divide 540, subtract 455 from 540, and what do you get? Have y'all done the math yet? 85. There you go. That's what he needs to have, which is answer choice G. A lot of people don't remember how to do this, but keep in mind we don't have to know what the first 5 exam scores are if we know their average. Okay, 53. Determine the number of real solutions there are for this certain quadratic given. Okay, number 1, a quadratic will never have 3 real solutions. So that one's out. Is it E, not enough information? Yeah, there's plenty of information given to you to figure out if it's got no 1 or 2. The thing you're going to do on this one is you're going to find the discriminant of the quadratic. Discriminant of quadratic. And I'm going to abbreviate. It's just what the number that goes under the radical. B squared minus 4 times A times C. So if you'll look, your B is negative 12. Your A is 9. And your C is 18. Grabbing a calculator, see what you get here. 144 minus something. 648. Okay, that's obviously going to be a negative number. When you subtract it, you get
Negative 504.
very good. If your discriminant is negative, you're going to have imaginary solutions. So your answer here would be no real solutions. So you might want to put, if you're not sure about this, if discriminant is greater than 0, you get 2 real solutions. If discriminant is equal to 0, you get 1 real. And if discriminant's less than 0, you get 2 complex or imaginaries. However you want to write it. There's no reals. And that's what we have here because our discriminant was negative. Answer choice A. Okay, and there's another circle problem on here. They like circles, obviously. This is another relationship you're going to need to know with circles. Have everybody got that? Are we good to go? Okay, I'm going to do my best to draw this picture. It will not be to scale, I promise you that, but this is the way I did it when I was drawing it at home. Okay. This is way off base, but anyway, they've got a 3. Wait, I should have 4. Yeah, I need to do 4. I was going, wait a minute, I'm missing something here. I'm missing a line. Let's try this. I need one up here. Okay, and I need one on this side.
I'm so tired.
Oh, y'all had prom last night, didn't you?
Yes.
Some of y'all did. I get it. I just thought y'all were having fun or something. I forgot about prom. I should have known. I work part-time at a jewelry store, so we were selling a lot of jewelry to girls.
What store?
Dusty's. So I just work part-time though. Okay, they've got it labeled that this is a 3, this is a 2, which is not accurately drawn, this is a 4, and this is a 1. Now, a relationship you need to know is these lines right here, when they barely touch a circle, they touch at one point, which you have to use your imagination with my drawing, they're called tangents. Okay? If you have 2 tangents intersecting outside the circle, these 2 segments are congruent. So that means this is a 2. Well, we've got 2 over here, so that means these 2 are congruent. That means that's a 3. We've got these over here. That means that's a 4. And we've got this one right here. And I'm just using little hash marks to show they're equal. It means that's a 1. With that in mind, you can find the perimeter of this quadrilateral, and that's what they're asking for here. So we've got 2 times 3 is 6, 2 times 4, 2 is 4, 2 times 1 is 1, 2 times 4 is 8. Looks like it's 19, which is the answer. Ooh, I misadded.
20.
What did I do
2
wrong?
times 1 is 2.
That's what I did. 2 times 1 is 2, so we get 20. Thank you.
Will that one be on that paper you're talking about?
Yes, that one, it should be. It's got everything on it. But it's, I want to warn you, it's kind of hard to read because it's got all the diagrams at top and all the equations at bottom. If I would have designed that, I would have done a picture, formula, picture, formula, picture, formula. So you're going to have to really watch it. But torturing my kids lately. My geometry class has been circled out. Thank goodness we're finished with them. They are getting tired of them. Okay, 55 is a pretty easy one. It's what I like to call a plug and chug. You are given a function. They want you to evaluate that function at -3. Okay, y'all go ahead and start working on it, and I will write the problem down. Our glasses on. Oh, thank you. That is great. And see, I still do that. Okay. Thank you. Wonderful. I don't care what Shane says about you. Okay. Let's see if we get the same answer. I'll cut me some slack. I'm doing this without a calculator. Okay, 42, 18. I have a feeling I didn't do that right, but. Did y'all get 193? I did that without a calculator. Let's see. Yep, that's what I got when I worked it the other day. Whenever I worked it. Answer choice C. Okay, what I did, I just wrote the equation down. You can do this on the calculator. Just plug everything in at once. You can do some of it in your head too. You can look at that and say, okay, -2, -3 is 6. And then I'll say, okay, 9 plus 24 plus 4. You can just plug it in however you want to. You can do some of it mentally and some of it on the calculator. That should be a quick problem to do. Okay, look at the next one. It says find the point B of a segment AB. It gives you A, it gives you the midpoint. You're looking for point B. So you need another midpoint formula. Midpoint formula looks like this. And I abbreviate it like this, midpoint formula. Okay. X of your midpoint, Y of your midpoint equals, you're going to add your X coordinates together, divide by 2. Add your Y coordinates together and divide by 2. Okay. Now our midpoint, is 1, 3. So we know this ordered pair is 1, 3. And one of our X that's given is -3. So we have a -3 plus some X divided by 2. And the Y they give us is 7. So we have a 7 plus some Y's divided by 2. What I do next is I just set them up separately. -3 plus X divided by 2 equals 1. Because you know this expression has got to equal this number. This expression has to equal this number. So we have 7 plus Y divided by 2 equals 3. I multiply the 2 over, I get -3 plus X equal 2. X has to equal 5. Multiply the 2 over, I get 7 plus Y equals 6. Y has to equal a -1. So it looks like my point B is going to be 5, -1, which is answer choice J. Wow, H, yeah, J. Y'all agree? That's one of the easiest formulas to know, in my opinion. Add your X's divided by 2, Y divided by 2. Okay, this next one's interesting. This is Those of you in pre-calculus shouldn't have any problem with this, okay? If you're not in pre-calculus, pay attention. Okay. Okay, notice that we're talking about a sine function. It wants to know which function has an amplitude of 4 and a period of 8, and every one of your choices is sine. It's a sine function. So the first thing you need to know is when you have some sine function that looks like this, okay, your amplitude is the absolute value of A, okay? Your period for sine is 2 pi divided by the value of B every time. So, since my amplitude is 4 and my period is 8, I know that my front number, I have to have a number in front of my sine that's either 4 or -4. Okay? So that eliminates B and E. So this is where I need to work. I need to know what B is. So I say 8 equals 2 pi divided by B, which means 8 times B equals 2 pi divided by 8. B equals pi over 4. So my equation needs to be either 4 sine pi over 4, pi over 4x, or y equals -4 sine pi over 4x. Both of them don't need to be there because this is true for both of those equations. So we look at our choices. A is out, B is out, C is out. Has to be D. Has to be D. Okay, those of you that are pre-K, you probably already know all this. Y'all probably worked equations that would look much uglier than this and had to find the period and amplitude and so forth. Have y'all done that yet?
We're just getting trick part.
Are you okay?
But I forgot it.
My pre-calc class right now, is doing sine, cosine, whatever functions that are this long and then solve for x. They're hating me right now.
We had to like draw them and.
And define A, B, C, and D. Yeah. So, those of you that had pre-cal, that's some of the basic knowledge you need to know. You don't have to worry about everything else. The next one. Find the measure of the exterior angle of a regular dodecagon. Only 2 things you need to know here is when you want to find the measure of an external angle of regular polygon, your formula is measure of angle equals 360 divided by number of sides. Next thing you need to know is how many sides does a dodecagon have? 12. So in this case, you're going to do 360 divided by 12. You get 30. So know your, I think the answer choice G, right? In this case, you need to know how many sides are in each type of polygon. External angle is the easiest one to find though. 360 divided by number of sides. Internal is not too bad. It's n minus 2 times 180 divided by n.
What is an exterior angle?
On a polygon like with a triangle, it's when you extend each side out in the same direction, this is external. There's external, there's external. So some of those should be 360. That means that'd be a 120-degree angle. But that makes sense because you know this one's 60 if it's equilateral. Okay, the next one. I was getting this problem mixed up with one we did previously. They give you a table and you have to figure out which equation fits it. On this one, I used my knowledge of y-intercepts. Okay, if this table truly depicts a linear function, then when you have x equals 0, you've got a y-intercept. So look at the table they gave us. X is 0, 1, 2, 3. And 4, did they give us? No, they didn't give us 4. Y is 2, 6, 18, 54. Well, you can look at your Y's, and you can tell that as X increases by 1, Y does not increase by the same value each time. It increased by 4 here, by 12 here, so you can tell it's not linear right off the bat. But you can also check y-intercepts. Notice your first two choices are linear. Your y-intercept is 2 and 3. Well, this looks like it has a y-intercept of 2, but if you continue the pattern, it's not going to fit the y values. So just by looking at these numbers, though, you can tell it's not linear. So the first two choices are out. Next, I would just try the formulas. 2 to the x power. 2 to the 0 is 1. It's not 2. So that one's out. Same thing with 3 to the x power. Your first y should be a 1. Your only choice is 2 times 3 to the x, which it works in this case, and you can check it every time. You get 1 times 2 is 2. 3 to the first power is 3. 3 times 2 is 6. 3 to the second power is 9. 9 times 2 is 18, so it works. Answer choice E. Okay, what problem was that?
59.
59. Yay! Are we going to hit the mark? Are we going to do good?
We're doing very well, thank you.
Good, 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 good. I'm trying to stay within 2 hours.
Well, we're close.
We're close.
We're all right.
Maybe a little over.
That's all right.
Okay, this is the last one. If you'll notice, it's a trapezoid. And notice it's got the non-parallel sides are called legs. Non-parallel sides. This one's parallel to this one. The non-parallel sides are called legs. And notice they're marked equal. They've got this bottom angle marked at 68, and they want you to find this angle. Multiple ways of finding this answer. You know, since this is an isosceles trapezoid, this is x, and this is 68. Another thing you need to know about trapezoids is consecutive. These two angles right here, x plus 68, they have to add up to what? 180. These two have to add up to 180 because they're half of the trapezoid. Okay? Because this side's going to be the other half. This is the easiest way to work this. 180 minus 68. What do you get? Okay? But, if you're not sure about that, remember that all 4 angles add up to 360, so you can do 2x plus 2 times 68 equals 360, solve for x. Stick a fork in me, I'm done. No, really. Do y'all have any questions?
Okay, there are detailed explanations after that practice test. Okay, thank you, Mrs. Golson. We appreciate you.
You're very welcome.
Everybody give her a hand.
No, y'all don't have to.
Yeah.